Bridge and Landings project is the largest floating bridge in the world. And as we're replacing it, we like to give people an opportunity, if we can, to come out and see the work. So some of the things we're going to look at today is some of the work we like to show on these public tours. As you can look behind me, you can see the existing floating bridge as well as the new floating bridge that we're currently building right next to it. As the area and the community has grown, need for transportation services has grown. So what we've done with the new bridge is it actually will have 2 general purpose lanes in each direction, and it will have a HOV lane in each direction, as well as full shoulders on both sides. In addition to that, we also have what we call the regional shared use path, which will allow for bicyclists and pedestrians and dog walkers to be able to cross the bridge, and it also creates an area for them to get a good view of what's going on with the lake. The current bridge, our east navigational channel height will be 70 feet minimum, and that's when the lake's at its highest point. The reason for that height is it matches the I-90, so people that have boats on the lake will be able to transit underneath the east navigational channel once we do open up the new bridge to traffic and eliminate the old bridge. Well, concrete floating and the bridge floating in general, it's based on Archimedes' principle, which is displacement of water in area. Each of the pontoons is about 75 feet wide, about 360 feet long, and about 28 feet tall. Once they come up onto the lake, there's 80 bolts that bolt each of those longitudinal pontoons together. 750,000 pounds of stress is put on those bolts to help hold this bridge together at 80 locations at each joint. There are anchor cables that come out into the north and one to the south in the center of those pontoons at every pontoon along the bridge. And they come out anywhere from a few hundred to over 1,000 feet. The purpose for that is twofold. One is so the bridge doesn't float away in a storm. The other key reason is those cables are tensioned up to about 60 tons of tension on those, and those hold the bridge in proper alignment. The new bridge is designed to carry an 89-mile-an-hour wind load. In other words, if we have gusts of 89 miles an hour, the new bridge should withstand that. These are called the supplemental pontoons I'm standing on right now. These are actually attached to the longitudinal pontoons that have the main driveway. The supplemental pontoons, many of them have this hole in the middle of them, or a well as we like to talk it. So what we found was the storm drain runoff water comes into the storm drain, comes down through these gray pipes you see here, and into the wells. The reasons it's important that it comes into these wells is because then it distributes any sediment that could get into the storm drain line deeper into the lake, and that's better for the lake environment. The reason for this yellow ramp is that certain types of birds, typically cormorants, would congregate into these wells because a lot of the juvenile or smaller fish would come in, and it's a great place to feed. Once they get wet, they need a running start to be able to fly, and so they could not escape the wells within the pontoons here. And so what we did is we built these bird ramps to allow the birds to actually walk up out of here once they get wet, dry their wings, and then fly away. As we stand here below the high rise throughout these pontoons, and as we come into the low rise, we do have a 75-year design life that the entire bridge is designed to and should be maintained. As long as with good maintenance, we shouldn't have any problem meeting that and beyond.